The mean value theorem for derivatives is a big deal for building the rest of calculus. So it's like the intermediate value theorem is going to come up on the AP test. You're definitely going to want to know the definition and you're going to put it on your green paper. And then we're going to practice a little bit using the mean value theorem in the way it's used on the AP test. It's one of those things where the way it's described in your book, it's all true and correct, but it's tested in a sort of a different way on the AP test. So, the mean value theorem. If, and only if, f is continuous over the interval a to b, the closed interval, so that's with brackets, a to b, and it's differentiable over the open interval a to b, then at some point between a and b, let's call it c, f prime of c is equal to f of b minus f of a over b minus a. So let's notice what this says. F prime of c means the derivative of f at c, which means the slope of the function, the slope of the tangent to the function, is equal to, what's this? Average rate of change, or the slope of the secant line, or the average slope. So the mean value theorem says, what you need to remember, some point on the closed interval a to b, the actual slope, the derivative, the slope of the function is equal to the slope of the secant line, or the average slope, using those points a and b. So a little bit about theorems here. I hope you remember from your geometry days. A hypothesis and conclusion. So the mean value theorem has two hypotheses and a conclusion. The hypotheses are the two things that have to be true if you want to try to use the mean value theorem. If these two things aren't true, you can't even bother to try to use it. So the two things in this case, if f of x is continuous on bracket, closed interval, a to b. That's the first hypothesis. The second hypothesis is f of x is differentiable on parentheses, a to b. So there are two hypotheses. F has to be continuous on a closed interval and differentiable on the open interval, a to b. If those two things are true, then the conclusion of the mean value theorem must also be true, which is at some point c between a and b, f prime of c is equal to the average rate of change. So it's your job to draw this into your notes paper, and then you have 2 or 3 pages in a row of problems where I give you a function, a picture. You have to draw on the secant line and then go looking to find the tangent, the place on the graph where you should draw the tangent, so that the tangent becomes parallel to the secant line. So the slope of the tangent, well, put it this way. If I have an A and a B, and I draw the secant line that connects them, that line segment that connects those 2 points on the graph, as long as f is continuous and differentiable on that whole interval, then somewhere in between a and b there's going to be a point where if I draw the tangent line at that point, it's going to be parallel to the secant line I just drew. So this is the most common way you're going to see the mean value theorem tested on the AP test. We have here some information that's been given about the function f. We know 2 ordered pairs on the f function, and we've been asked to prove the existence of a particular value of the derivative of f. Now, if I've been asked to prove the existence of a particular value of f, I might consider using the intermediate value theorem. The intermediate value theorem says given 2 points on f, every y value in between the 2 y values must get touched. Here they're asking me a question about the existence of a particular value of f prime. That's my hint that I'm going to use the mean value theorem. And here, this is sort of the least complicated way that this might get tested, because they've very clearly implied already what I should let a and b equal in this problem. So my first job is to make sure I can find a difference quotient, an average rate of change on f that's equal to this -1. So I'm going to try that. Is it true that f of 5 minus f of 2 over 5 minus 2. I'm hoping that equals -1, but I have to check it and be sure. I'm probably going to get 1 point just for writing this difference quotient. F of 5 is 2 minus f of 2 is 5 all over 5 minus 2. That gives me -3 over 3, which does in fact equal -1. So I have found a difference quotient, an average rate of change, using 2 for A and 5 for B, that is equal to that particular derivative value that I'm looking for. This is a really good sign. Now the other thing I have to do, I have to go back and I have to check. I'm going to try to use the mean value theorem as the reason, as my reasoning for saying that this f prime of c exists. But I can't try to use the mean value theorem unless I'm 100% certain that the function I'm talking about is continuous and differentiable on the interval I care about, which in this case is the interval from 2 to 5. So check this out. I've been told f is twice differentiable. So, and the no domain is given, so that means f must be twice differentiable across all real numbers. So my function f is differentiable. That's one of the things I need to know. And because it's differentiable, I know it must be continuous. So I know f is differentiable and continuous, so I'm going to be able to use the mean value theorem. I'm going to write it up using the typewriter. So here's my write-up. Since f is twice differentiable, we were told, it must be both continuous and differentiable in the closed interval 2 to 5. So since f is continuous on the closed interval 2 to 5 and differentiable on the open interval 2 to 5, the mean value theorem guarantees that there exists c. C is between 2 and 5, so 2 is less than c, which is less than 5, for which f prime of c equals -1. Where does that -1 value come from? It came from me using 2 as A and 5 as B in the average rate of change expression. So I could have, instead of working that expression out up top, I could have just written it once here, f prime of c equals f of 5 minus f of 2 over 5 minus 2, which equals -1. So I can show my work down here where I'm doing this, or I can show my work up here and then do the write-up. Either one gets full credit, but just know, even if you don't think that you can get if it's a test day, and you're not sure you can get the mean value theorem write-up correct, you'll probably get 1 point just for writing this average rate of change expression. So do at least go through that process of writing the average rate of change expression.